Hello, a little out of sequence video. I was challenged on my Discord server to code the game Breakout in 30 minutes, and I was to do it live in front of an audience. I'm not going to get into the habit of uploading my live streams, but I thought this one had enough educational content that it should be going on the main YouTube channel. Anyway, this is how I got on. Enjoy! So, the title of the stream is the Sign Hunters Challenge. Now, Sign Hunter is a member of the Discord community who had the idea that maybe I should have a go at trying to program Breakout as fast as possible. Originally it was 20 minutes, we negotiated to half an hour. I think it's probably going to be more like 45 minutes, but it might serve as a useful video for people who haven't used the console game engine for anything, and they can look at this and see how something is done from scratch. I'm not saying we'll get it all right and perfect first time, I also don't think it'll look very pretty, but we can see how we get on. Are the audio levels okay? Can somebody give us a shout? Let's have a go. I'm going to start a timer just because it's fun to start a timer, but I don't think I'll be able to do it in half an hour, but we'll see. I think we'll probably get it something done within an hour anyway. So let's have a go. Right, good, the timer's ticking over. So the first thing we'll want to do is actually include the console game engine. And then we want to overwrite the class that it provides, so we'll have to do that ourselves. So we'll call this one Breakout. Public, we'll see console game engine. And so the point is that the console game engine provides two functions in the background which the operator, or the user, will need to override to facilitate gameplay. We'll just stick in a constructor whilst we're here. Now, I've got to remember I'm on the clock, so I'm not going to be describing everything in too much detail. You'd usually stick a name in there. Let's do the two overridden functions. Void, oh no, it's not void, is it? It's bool. On user create, which is where we'll create all of our static resources. Of course, I probably won't be able to read the chat whilst I'm doing this. I'm not going to be pausing the timer. And on user update. And that passes in f-elapsed time, which is what we're using to keep everything in sync. Right, once we've got a class, we then need to create our main function. It's going to be my typing that's going to let me down with this. And we want to create an instance of our class. So in this case it's Breakout Game. Once we've got that, we want to create the console with the construct console function, and to that we pass in the resolution which we're going to draw things at. Now, because I've been using it a bit recently, I'm going to use 256 by 240 by 4 by 4. So that's the width and height in characters, and the size of the character is going to be 4 by 4 pixels. I'm going to assume that that's going to work, so we'll just call the start function straight away. Let's have a look. Oh, not going to work straight away. Where am I going? Oh, because I've not returned true from there. There we go. So if you return true, it doesn't cause the game engine to stop. If any of these functions return false, it will automatically cause the game engine to stop and clean up. So there we go. We've got a window running at a number of frames per second. Good. Don't read code. Where are the splits? Yeah, I should have some splits, but I need some splits to work against. Anyway, right. So how are we going to structure this? Ugh, not even thought of any of this. So we're going to need a level that represents the blocks. I'm going to stick with the old Jario way of doing this. I'm going to create a string to do that. So let's define what we're going to have as a level. I think a level is going to need a width and height as well. How wide is an Arkanoid level? I've no idea. I'm going to pick 16 pixels. What's 256 divided by 16 is 16. So if we get up sort of half the screen with blocks, maybe something like that. Okay. And height. and the height would be 16 blocks into 240. Hang on a second. So that's 15 high. So that's going to be the full playing field, 16 by 15. So let's draw that in. What did we call it? We called it level. Right, so to the level I want to do, so we want to make sure we count this out properly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So at the front, okay. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Right, let's put in some blocks then. So we're going to use the, for boundary blocks I think we'll use the hash symbol. Okay. Right, so let's just get it to draw the level to begin with. Firstly we'll probably want to erase whatever's there, so and I'm going to cheat a little bit by using the space character to do that. There we go. So let's draw the level. I'm going to assume a block is 8 by 8. Should we? Yeah, why not? So, 4 is less than height. So I'm going to do 2 nested for loops, and we're going to draw the contents of the level to the screen. So we want right, a switch block for the level at that position. Level y times n width plus x. Case. What did we have? So if it's a hash, that's going to be our boundary. So let's fill vect x times n block, comma y times n block, comma x plus 1 times n block, comma y plus 1 times n block. And what colour we're going to do, we want that to be a full solid pixel, and we'll set that to FG white. So the boundary of the level is going to be white. Got lots of little red squigglies there. Why is that? Oh, it's not fill vect, is it? It's just fill. So it's found a Windows command there. There we go. Fill. So that's for our regular block. Let's cut and paste that. And for empty space, which I'm going to use the period symbol for, we'll draw that as black. Let's have a quick look. Okay, it's a little bit smaller than I thought it was going to be, but maybe this is a scale to work in. We can play with the numbers later. So, let's just put in some other types of block in here. Insert. We'll use the numbers 1 to represent a block. I don't know, maybe later on, maybe not for this challenge, but if we choose different numbers, perhaps that's how many times you have to hit them before they disappear. But let's just fill that in for completeness. So we also want if it's a 1. See, I do use the insert key. All those VS Code people that don't have it, and we'll set the colour of the block to be green. Why not? Okay. So let's now draw in a bat and add some user control to it. We'll try and work in the floating point domain for bats. So the bat's only really got one position, hasn't it? It's just going to be bat, I suppose. And we'll set that to the middle of the playing field, which is going to be something like 64. We'll see. Let's draw that in too. So for the bat, we'll just draw in a line for the bat width. We might want to play with bat width later if we're going to add power-ups and things, but we'll see. So let's set that to being 10 either side of the centre point. That might become important for us. So let's draw a bat. Draw a line, f-bat, take n-bat, comma, where are we going to draw it? Well, it's going to be n height minus a little bit. N height times n block minus 2, why not? F-bat plus n-bat width, and the y is the same, so that should be bat width. And we'll draw that as pixel solid, and again we'll draw that white. We'll just keep that one up here, that looks like it might be quite useful. Let's just see if that's drawing a bat. Not drawing anything. Have I got... Oh, no, it did draw something, took too long to start up. There we go, okay, so we've got a bit of a bat. Let's add some controls for the bat now. So we're going to use the get key, we'll use the left and right arrows. And it's only if it's held down do we want to do anything. So if the left key is held down, we want to decrement the bat by, I don't know what the speed is going to be yet, but we'll see. Let's choose a number. F elapsed time. And if we want the right key, we want to do the opposite. Now, we've not put any constraints on the bat yet, so it's going to sort of drift all over the place. So left and right key. Oh, well too slow. Way too slow. So let's up that up. Let's change that to 30. Ah, nothing. What's going on? Ah, helps if I'm pressing the right keys, doesn't it? There we go. So that's probably still too slow. Let's double that speed. Okay, so we've put a bat in. Right, now it's time to add a ball. And we'll just start the ball somewhere in the middle as well. I don't know how far down it's going to be, but we'll probably be somewhere about right there. And we'll also need a direction that the ball is travelling in, won't we? Now, should I use it using an angle, or should I just do it with deltas? I'm just going to do it with deltas. F-ball dx, we'll just start that off as... Well, we'll have to calculate that from an angle, so... dx and F-ball dy. So let's do that here with a bit of code. I want to pick a random angle for it to start with. Yeah. Rand divided by floating point random number, please. So that's giving me 0 to 1. That's all of that. Times... Oh, it's 2 pi, isn't it? Yes. 3.14159 times 2. No, that's good. And so we'll set our ball dx equals cos f of F, because this way I know I'm going to get a unit vector for the speed of the ball. Okay, so if we've got a ball, we need to draw the ball. What should we do for a ball? Should we actually use a circle? Yeah, why not? Fill circle, f ball x, comma. Now I'm going to cheat a little bit. Even though I'm going to set the ball's radius to be something like 2 or 3, I think for the collision I'm just going to keep it as a single unit, a single pixel ball, because we'll have to faff about with the collision otherwise. So f ball x, f ball y, radius, let's set that to just 2 pixels. Ball is going to be a solid again. FG yellow. So let's just see if that does indeed draw a ball. Yep, good. Right, so now we want to update the physics of the ball, and we'll do that after we've moved the bat to give the player a chance. So, this is where it gets a bit tricky and fun now. Let's have a look. So, the ball needs to have its position updated, so ball x plus equals... Do you know what I'm going to do actually? I'm going to maintain a cache of where the ball was. I think that's probably how I'm going to solve the collision detection. Let's see. So if ball x plus equals f ball dx times f elapsed time times some speed, which we don't know what it is yet, and we want to do the same for y. So we'll just stick that up here in our sort of temporary constant area. F speed equals 20. Let's just have a feel for how fast that is. Really slow. Also, disappointingly, it's also just sort of gone straight. Why is that? Debugger and have a look what's going on. So dx is that, and dy is a little tiny number. Well, maybe it's just an unfortunate coincidence that's how it started off. I'll tell you what, we'll make it, instead of being random to begin with, we'll just have it rank equals, I don't know, 0.6. See what direction that goes. Okay, good. So let's get it to bounce off solid objects. So to do that, I want to work out whereabouts in my array I am. So that is simply int n cell x equals the int value of f ball x minus... No, it's not minus. It's divided by block. Something similar for y. Okay, and I'm also going to get cell new x. And we'll do something similar for cell old x. Which is going to be using the older variables. And the reason I'm doing this is because I'm going to make a check on the whether a collision has occurred by looking at was the ball in an empty cell before it was in an occupied cell, because that way I can also work out, let me get this right, I can work out which direction I've hit the cell from, which I'll need to do in order to deflect the ball appropriately. So this. Right, so let's just see what happens with a new cell. So if Let's actually grab the contents of the cells too. So char new cell equals level and new cell y times n width plus n new cell x. What have I got wrong here? Oh, blood. Not got time for these sort of amateur time-wasting mistakes. And of course that's not new, is it? That's actually old. And that one's old. And that one's old. Right, got there in the end. So, if new cell equals, let's just do it, let's just test to see if we can get the collision sort of working first. If new cell is a solid wall, as in it's the boundary, then we need to work out which direction have we hit from. So I can do that by saying if n new should have called these new cells, shouldn't I? Cell new x is greater than n cell new y. Sorry. Old x. That way I've hit the coming from the left, so that's a collision in the left axis, so I want to invert in that situation. Let's just see what happens there. So the ball's coming along. There we go, so it bounced off the wall. Okay, it's gone out of bounds. We'll worry about that in a minute. I think we'll just speed the ball up, because I might make it move a little bit quicker. Let's do something similar for Y. And I think just to test all of this out, I'm going to put in an artificial floor for now. I don't think I'm going in the right direction with this, but we'll see. Yeah, okay, so that drifts off into the middle of nowhere. So I'm ending up with some sort of circular logic here that's not going to make any sense. Bouncing off those two corners. Okay, so that's a ball bouncing around. Good, good, good. What we shall also do is, in the event of it not being a full stop, so if it's empty space, if new cell equals our 1, get to brute force this in, copy you. If it's a number, I'm just going to set the number to being a space. Okay, okay, okay. So if it hits anything, it's going to invert its direction. If it hits a number, it's going to change that to a space and still invert the direction. Oh, look at that. Okay. Right, so now we want to worry about the bat. So we now a little bit of a check in the bat. If f ball is greater than, where did we position the bat? Where did I put it? N height times 2 minus, yeah, take that. Right, so if the f ball y is greater than the bat position, vertically, then we want to check, is it within the bounds of the bat? If f ball x is greater than f bat minus n bat width, and f ball x is less than f bat plus n bat width, let's just stick some brackets in there not to tempt fate. One, two, three, four, five, probably, it'll tell me. Right, if it's the, so we've hit the bat, we want to invert the y-axis. Else dead. At which point we'll we'll set the ball to be f ball x equals n width divided by 2 times n block. And we'll set the y to be somewhere also in the middle. We also then need to randomly choose an angle again. So we'll just take all of that. Right, so let's just remove this wall. Okay, it bounced off the bat. Come on, ball, faster! And let's just try and die and see what happens. Okay, so the ball gets respawned somewhere and the game continues. I think we want the ball to just be a little bit quicker. So it's a really good song to have in the background when this is playing. So we just want to constrain the bat now, don't we? So that's here. So if the f bat minus n bat width, no, that's not true. If f bat, yes it is greater than, sorry, is less than n block. Now we want to set that. F bat equals n block plus n bat width. And for the other side, if f bat plus n bat width is greater than n width times n block, then we want to set f bat to be that. F bat equals n width minus n bat width. So forget about trying to stop the ball, let's just make sure the bat doesn't get... Oh! Semicolons! Semicolons! Okay, kinda gets there on that side, stops solidly on that side, so it's width, take 1. So, knowing that, let's just stick in a few more blocks, put an interesting shape in there. this one is greater than n width times block. Ah, come on, don't let me down now. How are we doing? Almost there. Ah, big crash. Why has it gone through the bat? Well, I think, with your acceptance, is that good enough for Breakout in half an hour? Can I stop the timer? I think that's not bad. I mean, we could add more bells and whistles to it, but there we go. 29, 26, 75. There we go. Oh, never been so nervous in my life. What I need is a TMR. Is that the right thing? There we go. There we go.